conversion process. So before we understand this conversion process, let us go to this paint that I have created for the explanation. So we will do only this part now. So this part, and we can see here. So this is how the conversion will be taking place. So we have a result, and that result is available in address age, and there will be 8 bit out of 10 bit. 8 bit will be in address age due to the left justified. So 9, 10th, 9th, 7th, 8th, in this way 8 bit will be here, and the rest 2 bit will be in address age. Now this 10 bit, if I want to copy to any variable, that should be at least 10 bit long, and we know there is no variable that is of length 10 bit. So we have 8 bit unsigned character and integer has 16 bit. So we will select, definitely we need to select this integer variable. So this integer variable will be of 16 bit long. And now whenever I will transfer this address result to this integer variable by assigning this value, so I can just assign this value x equal to address h, then automatically that will transfer, and then the lower order 8 bits will be having this 8 bit result, and the higher order bit will be blank. So there will be nothing in the higher order bit, so it will be blank. So these are all will be blank. Okay, these are all will be blank. Now I want this is done correctly, that address is transferred to this x variable. Now I need to copy this most significant bit of address L to the least significant bits. So first thing I need to do, I need to make these two place backend. So I can do it by shifting this result to the left. And how many bits? I need to make backend of 2 bits. So that means this has to move 2 bits to the left. So this can be done by doing the operation x equal to x less than 2 bits. So I have to write down this operation, then it will be shifting to the left. Now I have 2 place now available here, and that has to be copied. And how to copy? If I just do the addition, then this is the 8th bit, so I will have 8 bit will be changing. So this one will be added here and this one will be added here. So that means I cannot directly add this one. So what I will do, I will shift to the right. This 2 bit has to be shifted to the right. So that I will do by writing address L should be equal to address L, and that will be shifted to the right by 6 bit. So that will shift to the right, then my result will be this one is on the left. Now if I add these two number, this one, and this one, then these two yellow bit will be copied to the least significant bit, and the rest of the 6 bit are 0. So if I add this, there will be no change. Okay, so that what we need to do. So that means I have to first declare a variable, and that variable has to be loaded with the address age, and that x should be shifted to the left, and this one address should be shifted to the right, and then I will have the result ready. So that means I can now discard this one and I can start processing the result. So first thing is I need to declare a variable. That variable x that will not call any function. So this processing is mainly inside my main function. That's why I can just declare this variable inside my main function. This is x. Now I will copy this address x. So x would be equal to address, and then I will be shifted to the left, or let me just do in separate statement, and then x will be equal to x shifted to the left by 2 digit. Then I will change the address L, that will be address L shifted to the right by 6 digit, and then I will do x should be equal to x plus addrsl. So that means this code that was in address H and address L that I have successfully copied to this X. Now this is still being a code. So that code is representing one of the 1023 levels. So this code will be simply one of these code. So it can be vary to any value. Now if I draw